Hey everyone, let's continue our discussion on matrices, and I want to do a couple of things that are a little bit different. First thing I want to do is talk about an additive identity. So let's take a matrix 1, 2, 3, and 4, and I want to add to that matrix and get the same matrix. Well, that's pretty easy. It's just going to be a matrix with all zeros in it, and I get 1, 2, 3, 4 again. Right, so the additive identity is just the matrix of the same size, even if it is not square. So if it was a 3 by 5 matrix, then it would be a 3 by 5 set of zeros. And that you would add that to the first 3 by 5 matrix, and you would get the same thing. In a similar fashion, the inverse, the additive inverse, is just the negatives. So 1, 2, 3, 4. If I add to that negative 1, negative 2, negative 3, negative 4, I'll get 0, 0, 0, 0. All right, so the additive inverse and the additive identity, nothing very exciting there. But what about multiplicative? So the multiplicative inverse does have to do with ones, but it isn't 1, 1, 1, 1, right? If I change this matrix to 1, 1, 1, 1, all right, so let's do that. If I do that, I get 1 times 1 plus 2 times 1, right? So I get 3 in the very upper left. So I already know that doesn't work. So what does work? Well, it turns out the matrix would have ones along the diagonal from upper left to lower right and zeros everywhere else. So if I need a 3 by 3 or a 4 by 4, then it's going to be ones all along that upper diagonal from upper left to lower right and zeros everywhere else. It doesn't matter if I have a 3 by 5 matrix, and we'll talk about that in a second, it's still a square matrix. How big a square matrix? That's what we'll get to. But let's check this out. So this is 1 times 1 plus 2 times 0. So that's 1 plus 0, so that's still 1. And then it's 1 times 0, as I go to do this entry right here, it's 1 times 0, which is 0, plus 2 times 1, which is 2. And then lower left, at the lower left, I'm going to use 3 times 1 plus 4 times 0, so that's 3. And then the lower right, finally, I'm going to get 3 times 0 plus 4 times 1, which is 4. And so you can see I ended up with the same matrix that I started with, and this should be multiplication. All right, so I'm multiplying those matrices together, and I get the same matrix. Is there a multiplicative identity? The answer to that question is yes, but I'm very not expert in multiplicative identities. I let my calculator do all the work. Sorry, there it is. So I can take 1, 2, 3, 4, multiply it by something with an inverse, and I'll get 1, 0, 0, 1. Order of operation matters, and we'll get to that later because we will utilize the multiplicative inverse, just not right this minute. Okay, so let's not worry about that one. So what about a bigger matrix? Let's do a 2 by 3. So what about 1, 2, 3, 4, 5, 6? So there's a 2 by 3 matrix, right? 2 by 3 matrix. Remember, if I'm multiplying two matrices together, then the second matrix has to have the same size as this second number. So this has to be a 3 by. And then all inverse matrices will be square, and I know that because my final answer needs to be a 2 by 3. So in order, remember, these two numbers have to be identical, but the outside numbers will tell me the dimensions of the matrix. So this is going to have to be 3. If I want another 2 by 3, I want the same thing, right? So it's a 3 by 3 matrix, 1, 0, 0, 0, 1, 0, 0, 0, 1. All right, and there is the identity, the multiplicative identity. So when I multiply these two matrices together, I get 1 times 1. Right, I'm going for the upper left. Don't need it that big. The upper left term, this is going to be a 2 by 3. So this guy right here, 1 times 1 is 1, plus 2 times 0 plus 3 times 0. So I'm going to get 1. Okay, let's move to the lower left. So that's going to be this row and this column. 4 times 1 plus 5 times 0 plus 6 times 0. And that's going to be 4. Okay, middle, I'm going to do top row, second column. 0 plus 2 plus 0. So that's just 2. 0 plus 0 plus 3, this is 3. And you can go on from there and you'll see that this is 4, 5, and 6. So I have this concept of an identity, a multiplicative identity for a matrix. And it's always going to be square, even if I'm multiplying by something that's not squared. The identity matrix will always be square based on the number of columns. And you'll end up with the same thing. All right, so there's a quick introduction to identities. We did an additive inverse. I'm not going to go into a multiplicative inverse. I'm going to let my calculator do all the work there. Okay? All right, if you have any questions on that, please leave them in the comments below. Thank you.